Okay, here's another inverse trigonometric problem. Suppose a stage light is 30 feet above the stage and 20 feet away from the back wall of the theater. If the director wants it aimed at a spot 8 feet off the floor, at what angle should it be aimed? Now I admit I'm probably going to show a lot of ignorance about theater in this problem, but here's how I envision it. There's the stage. Bang. There's the back wall of the theater. There's a light up in the rigging somewhere. It's 30 feet off the ground and 20 feet away from the back wall. We want it aimed at such a way that it shines not at the very, shines at a spot 8 feet off the ground of the back wall. We want to know its angle X from straight down. I suppose maybe you leave the lights all pointing straight down. I don't know. Maybe things aren't worked this way. What do we have here? Well, where's our right triangle? I think the right triangle that I'm envisioning here goes down, comes over, and like that. You can't do trigonometry without a right triangle. So we have this triangle like that. It's got the angle that we want built in there. And what does it look like? It looks like there's the angle X. This is a right angle. It's 30 feet minus 8. This is 22 feet over that way, and it's 20 feet across this way. We want to know what that angle X is. Now this gets a little bit tricky because this 20 feet is opposite the X. It's not touching the angle that we're talking about, it's opposite it. Now usually, and that is the adjacent, and this is the hypotenuse. So often our triangles pointed a different way. Don't always realize the hypotenuse is the longest side, the opposite is the one that doesn't touch the angle, the adjacent is the one that does. The angle X is always between the adjacent and the hypotenuse. Anyway, we're looking at adjacent and opposite as the two things that we have information for. And so we break out our SOHCAHTOA, and A and O is TOA. So we're talking the tangent of X is opposite over adjacent. The tangent of X is 20 over 22. And we can take the inverse tangent of both sides. And that will eliminate the inverse tangent and tangent. They undo each other. That's what tangent inverse does. X is the inverse tangent of 20 over 22, which could be reduced, but hey, who cares? We take 20, we divide by 22, we get that. We say inverse tangent. I did the wrong one. Where? 20 divided by 22 equals inverse. I did tan H. Ha! Just regular tangent. 42.3 degrees. X is approximately 22. 42.3 degrees. 42.3 degrees. Now I'm thinking if these are almost the same, 22 and 20, it's close to 45 degree angle. And I realize a real director is going to make some stagehand go up there and monkey around with the light, and they're like, up a little higher, maybe a little lower, maybe a little higher. But if you had a seriously anal retentive director who wanted things to the letter, and they knew it was going to be to a spot right there, 8 feet off the ground, you could do the trigonometry and figure it out. How you would measure 42.3 degrees, I'm not sure. I suppose you could have a light that had some sort of built-in angle measuring device. Maybe they do. They probably don't. Anyway.